Hello everyone. Just to show everybody, this is the gel bead heater. Has a polyamide heater on the inside, 30 watts on each side of a refrigerated blood pack. Just laying this across it. This is a test. The edges of this bag are not actually together. What we're going to do is I'm just showing it being warmed up, and after about a 5-minute elapsed time, then we will check the temperature out, see if it feels like it's close or where we're at. Basically, the gel does two things. While it's heating up, the gel is a heat sink, so it's absorbing some, let's say about half on each side of what would have gone into the gel pack. So about 30% or so of the heat is being absorbed by the gel itself right now, because it started at room temperature. The blood bag though started at, I believe, 37 degrees, and we're warming it up right now. So I'm just kind of taking a test, so it feels still normal. We know it's on. Right now we're running at 60 watts total. That's 30 watts on each side. And just in case anything crazy happened, I wanted to have it on video, like it, a bag popping open or, anything crazy like that. So, but I think it'll be pretty uneventful, because I did already test 1 liter of these, and it took about 30 minutes to heat up to about 100 degrees Fahrenheit with 2 of these heaters. But this is about a third, maybe a little bit more than a third. So we have 350 milliliters for the blood, and then we have these. So maybe half for the volume. Just want to see how long it takes to actually warm up. So I can tell the gel is getting closer to. Just want to test on the. Okay, I can certainly tell it's warming up. Because it's not as cold. It's a little warmer right here, which is where the pad's touching. Not so much on the sides. So we do have a warm spot here. And it's kind of be expected. Now something we can also do is put a piece of a thermal shielding right over the edge of the heater itself if we need to. That way it heats up the gel first, and then the gel transfers into it. But the goal of this is to be able to get the blood warmed up in about 15 minutes. In third world countries, disaster areas, stuff like that, where they don't necessarily have big warmer machines plugged into mains current, instead they would use either multiple bags of saline, mixing them together to cut down the blood so that it is not as cold, making it safe, but that still doesn't actually warm it up. That just brings it closer to room temperature. And the other option is to heat up water, which is usually done in something like a 5-gallon bucket. Once that's filled up, they would drop their blood bags in it, and they could have maybe 2 or 3 blood bags in there, and it would take them about 30 to 45 minutes for them to get up to 100 degrees. They'd have to have water in there at about 120 degrees, because they had to have a temperature differential to raise the temperature up from the blood, and they had to have enough mass in there to offset it being very refrigerated. And usually when you put in, blood, usually it's more than just one unit. You usually have more than one unit ready to go, at least two. Because what if you put in one and you need another one? You need it now, not in another 30 to 45 minutes. So they're going to go ahead and put in two, from my understanding, is normal. And then maybe some saline platelets and things like that, which are other components of blood that kind of, in totality, raise what's in the body. So I can see visually that the gel has changed a little bit. It's actually expanded slightly. Maybe if you scrub through the video, you might see that change a little bit. So we're a little bit over 5 minutes right now on the counter. So I'm just going to, okay. So I can feel that it's certainly warmed up to maybe 80 or so on the gel, and it's more so warmed up here, and it's kind of to be expected. That is where the heater is, and maybe a little closer to room temperature on the edges over here. Just going to flip this over real quick so that we can, okay. So, it's very warm here in the center of the blood. When you go to the edges, now it feels like we're down into the maybe 50s and 60s. And just kind of giving it a squeeze. You can certainly see on the inside. Once you're moving around a little bit, you can feel that there's some cold spots in there, and that's going to happen. I mean, you got a little bit of coagulation going on, stuff like that. So, but we still have the warm spot that's right here. So that might be something that I'll want to adjust. Possibly, maybe putting the heater on the complete opposite side for the warming. Matter of fact, you know what? Let's try it out. We'll just go ahead and do that now and flip it over. There's certainly no problem with that, I don't think. Just the transfer is much lower. What I'd probably like to do is get maybe another layer of this, a thin layer over the polyamide, because that's pretty warm. I would say it's probably a good 120, 130 degrees. Like I would want to just keep my hand on it forever. And our goal here basically in this first test is to be above body temperature at 15 minutes. That's really the long term, or well, this test's goal at least. If it doesn't make it, we'll have to look into some other options. One of the things that I have considered is doing, this is the thinnest layer of gel, so this is just one bead thick, okay, using the water beads as a fast method to make gel. Cheap too, water beads are pretty cheap. One of the things that could be done is to embed the heater into the gel itself inside a bag, and go ahead and seal them together. That way much of the gel itself is going to make sure that you've got more of an even heat distribution going on here. That is pretty cool though, because I can feel it through the gel. It's definitely warm. I can tell at this point the gel is definitely a little over, a little over the 100-degree mark. But it wouldn't bother me at all to put, I've got 4 of these heaters, it wouldn't bother me at all to maybe put 2 in each side of this inside the gel, and that way it would heat the gel faster, because this gel has a slow transfer. It has the same mass, well, very close to the same mass, at least roughly 95% of just that of water, because it's mostly water anyway. But because it has this polymer material binding everything together, it slows it down. So that's bad for the heating process. It's good to keep it warm, because once this blood is warmed up and it's administered to a patient, then it's probably not going to be very long before it's going to be in the body. So it's probably only going to be 30, maybe 45 minutes from the time it's actually warmed up to get to the body, connect it to the IV, get the air out, and it's flowing in with, you know, saline and platelets, whatever they decide to put with it. It's not going to be very long, and it's not going to take that long to actually get into them. As a matter of fact, if they're a disaster victim, they might even put it in a pressure bag, so that which is like a pressure cufflet that goes on your arm, and they pump it, and that forces it a little bit faster than it would gravity feed in. Sometimes you have to do that too if you don't have a pole to hang it from, like you would on a traditional bed. If you're in a cot or a stretcher, something like that, they might not have something high to hang off of, and the person would have to hold it unless they put it up under pressure to gradually force it in. So you can probably notice here the change in how the beads look. They kind of look like they're a little, gummied a little bit, and that's because they've, as they warm, they kind of get shinier and lose that frosty look. And you're only going to see that on this side, because the other side has a heavy texture on the bag. And that's what we're looking at here. So what I'm going to do, I'm really thinking that it would be better, because we do have quite the warm spot here, and we're a little cool over here, but we're almost done. We're almost there. It's a little bit warmer here. I don't have a thermometer. I'm going to probably pick up a thermometer tomorrow, but I'm going to guesstimate this is roughly about 110, 115 degrees right here in this spot, and then radiating outward, which isn't directly touching in every place. I can certainly tell that we're almost done. So most of it appears to be above 100 degrees, but maybe right here at the tips where there's not much flow, as far as, it's the farthest away, I can tell this is still down into the maybe 80s right now. So what I'm going to do here, we're going to flip this over, and this should slow it down actually a little bit, but I want it to be more even. Even is more important to me than it would be to be fast. Okay, so I think I accidentally pulled my wires out, so I'll have to pause this for a second. You don't have to look away or anything, but I'm just going to reconnect these. I do think this is going to be the way to go, though. So what I could do is take this whole assembly and slide this into a larger bag, same material. That way these are not directly, these polyamide heaters, which are pretty warm. They're, like I said, I would estimate they're 130, 140 degrees. If you just kept your finger there, it would be like a hot shower. So they're not getting to the point where they're going to foul the blood and damage blood cells. But, I still want it to be pretty even. There's just a pet peeve of there, it needs to be right. I would prefer it to be a little better, because the other thing is, as soon as you're done heating and you unplug this and take it to a patient or whatever, You want it to stay warm for the whole duration that it is being used. You know, the foreseeable future, which is only going to be about 30 to 45 minutes before they're going to end up switching another bag. And during that time, you know, you could be warming another one. So general idea here. At first, I was going to keep the heater on the bag, but that seemed like a waste of resources. So now instead, have the gel in the bag, keep everything warm. It only needs to be pre-warmed with the blood in it, and then once it's pre-warmed, you just leave the blood in it, and you can go ahead and administer it right away with it still in the bag, so it keeps it warm. Or you can slide it out. We're going to use it immediately, and you just don't really need it to stay warm. And you can use this as a stationary warmer on a table or something. So there's a dual use that you can use it that way. So yep, got some warmth coming back up off of it. Nice thing about these heaters is because they're so thin, they do pick up their heat pretty quick, and it's not quite as fast as a light bulb, but it's pretty quick. Well, for those people who had incandescent bulbs, I guess nowadays LEDs don't get hot very quick at all, do they? So and what I'll do is I'll probably try different combinations. Okay, so we have messed with this a little bit, and okay, so just want to check it out. So we definitely have a warm spot here. We have a warm spot here, and when I say warm, I'm saying just a little warmer than the outside areas, and it does feel more even doing it this way on the gel, so that's cool. But this guy's ready to go. This guy's body temperature. Yeah, I'm confident that this one will be ready to go. Like I said, we'll get a thermometer, get some more exacts here a little bit later. But let me just put that to the side. And what I'm going to do is we're going to go ahead and do round 2, and I'm going to have these flipped for the entire time. Okay, so it's only gel on this side, and see if we can still hit it in 15 minutes. But what I want is not to have just a warm spot right here that's radiating out. I want to more evenly warm this guy up. Okay, so we've got 2 other bags to be able to test with. I can put this one back into refrigeration, but and we'll go from there.